think it's probably been a while since you did absolute value equations and inequalities. If I remember correctly, I haven't taught algebra 2 in a while, but I think chapter 1 and algebra 2 you do absolute value inequalities. Definitely algebra 1 you do inequalities. But the big thing is remembering how to set them up and remembering that they're a compound inequality. So it could be an and, or it could be an or inequality. I'm going to remind you what that means. I used to have in these notes the way the book wrote it, and it was super wordy, and I felt like it wasn't an effective way to show you absolute value inequalities. But, side note here, absolute value equations, let's say the absolute value of x equals 7. Remember that the definition of absolute value is it's a number's distance from 0. So you can say that's the same as saying x equals 7 or x equals negative 7, right? Remember that? And we could make it more complicated. Well, the same thing is true for inequalities. When you see an absolute value inequality, you can have two different things happening. You could have that u is less than a, and you have to do the negative side. But remember with inequalities, when you make the other side negative, you have to flip the inequality. So we always say, rewrite the first one as u is less than a, and then the other one, we're going to flip the inequality and make the other side negative. That's what we did in Algebra 1 when we taught this. Now that we're in super cool precalculus, we can take this and instead of writing it as two separate inequalities with the word and in between it, you could write it as one inequality, right? We could say everything less than a but bigger than negative a. You agree with me that this is the same as this whole thing? Just putting it together. We're actually going to write them in interval notation when we do them today. And maybe you remember from Algebra 2, I don't know if Mr. McClure taught you this little shortcut here, that if you have the absolute value here and the number here, or the quadratic here and the number here, less than always means and greater than always means or. When I took tests like this when I was in high school or even college, that's the first thing I wrote on my paper at the top, less than and greater than or. Or you just say it enough times, less than and greater than or, less than and greater than or, and you'll always remember. Less than and greater than or. So, if I have the absolute value of something is greater than a, greater than means or. And again, you can set it up two ways, and I wrote it here, this is the book's definition here, that if you see that, it means this. But again, notice where that's coming from. You just rewrite this without the absolute value. U is greater than a, or U is flip the sign, make the other side negative. Right? That's exactly what this says, and that's how absolute value always works. And then you just solve them and graph them. Well, we're not going to graph today. In algebra, we graph. Obviously, maybe the same thing would be true if we had less than or equal to, greater than or equal to. I just did the less than. Your book writes all four of them out, and I'm going to save you the trouble for doing that. But if you need to write that, you can. Less than and greater than can be replaced with less than or equal to, greater than or equal to. So we're going to do a couple of these, and then we're going to jump to the quadratics. Yes? Stop me if I'm going too fast. The big thing that I want you to do today when you're doing these is we're going to write our answers in interval notation. On your quiz that we have on Thursday, the directions will be at the top, and I will say this a couple times before you take it. Any inequality that you solve on your quiz, you have to write the answer in interval notation. I really want you to get used to using interval notation. When I see this, the first thing that I do is I figure out whether it's an and or an or, so that I know how to write my answer. Less than means and, greater than means or, so I'm going to write next to this and, so I remember when I'm done solving it to put it in an and inequality. And then every time, we're just going to do rewrite it without the absolute value, and rewrite it without the absolute value, but I'm going to flip my sign and make the other side negative. That gives me my two options for absolute value. The big thing is just remembering that, because solving this is really not something that should be too complicated for you. The bad thing is when people forget to make that second equation, and then they miss half the problem. But when I subtract 3, I'm going to get x is less than 2, and x is greater than negative 8. Back when we did this in Algebra 1 and maybe even in Algebra 2, we would always graph this on a number line. And I'll show you this one, but you don't have to graph these on your homework. But you could. If we were going to give the answer to this absolute value inequality, we would say it's everything less than 2, not including 2. Oh, I know I should use my parentheses there, not my open circle. But greater than negative 8 at the same time, right? So we can say and usually meets in the middle, or usually goes in opposite ways. There are special cases, but for the most part, that's what it looks like. You could write it like everything greater than negative 8 and less than 2, right? All at once. I don't care if you write it like that or not. What I want you to do is write it in interval notation. So how can I take this and write it in interval notation? Like we did on P1 day with my brackets and my parentheses and my big hint is right here. What am I doing here? Okay. Parenthesis, negative 8, because this is not included. That's my lower bound, and it goes all the way up to my upper bound, which is 2, also parenthesis, because it's not included. This would be the solution to this. So just try to remember to write them like this. I think it's been a while since I looked at this section homework, but I think the back of the book writes their answers like that. So maybe if you forget and you look back there, it will remind you. Try this one. Figure out whether it's an and or, set up your 2 equations, see if you can solve it. And then we'll talk about the interval notation. Less than and greater than or, so greater than or equal to, I knew that was an or statement. And then you just want to solve those. Notice this one I flipped my sign and made this one negative, so you just want to kind of check to make sure our numbers match here. Remember, fractions are okay. Don't be scared of fractions. You're actually going to get fraction answers a lot in this class. Back in algebra, this would have been a fine answer here, but we're going to write it in interval notation, so that's the extra step that we're taking. And notice that with an or statement, you can't put it all as one thing. An or statement's not going to be able to be written like this, because this one is going to keep getting bigger forever, or it's going to keep getting smaller forever in this one. So you're actually going to get 2 intervals here, and I'm going to show you how to deal with that or sign. Greater than or equal to 7/3. 7/3 is the smallest that we get, right? So that's going to be bracket 7/3, because it's included, and it's going to go to infinity. Parentheses. With me on that one? Oh, someone on their homework quiz, I don't remember if it's this class or other class, but they wrote 8 instead of infinity, and I know they meant infinity. But it was definitely not an infinity sign. Or less than or equal to exclusive bracket, right? And you could write the word or, but to be mathematically correct, if we're going to write this, we're going to write the symbol for or the symbol for union, and you get to write a big U like this. That means the union of those two, or basically when you read that, it's this or this. And you look in the back of the book, it's going to have stuff like that. So we can make it very official now that we're in precalculus. When we have a quiz over this, it's going to be my big reminder for you as you take it. Check your answers and make sure you write them in interval notation because I want you to be practicing that. Questions about that? It's not that bad to solve it. It's just remembering whether it's and or and the interval notation. The other thing that we're going to do is quadratics. So let's look at solving a quadratic inequality. And there's a few ways we can do this. One way we could do this, and that we did in Algebra 2, I say we because I used to teach Algebra 2, but when we do these in Algebra 2, we graph them, we make the lovely parabola, we find the zeros, and we figure out whether we're shading inside the parabola or outside the parabola, and then that is your solution set. And that works here as well. But algebraically, it's probably a better way to do it, especially if it didn't cross nicely on the x-axis. So we're going to solve this algebraically today. Step 1 is you're just going to solve like it was an equation. So I'm just going to put solve like an equation. So kind of forget that it's an inequality and do it like we did on those worksheets. Like what if it just said x squared plus 3x plus 2 equals 0? And then we'll deal with the inequality part in a minute. What are the 3 ways that we have that we can solve quadratics? Complete the square, quadratic formula, factoring. I don't care which way you use. Most of the ones today are going to be factorable and probably not bad to factor. So I'm going to factor most of these, but if you're not a factoring fan, quadratic formula, complete the square is going to work out exactly the same way. But this one, I just can't help myself from factoring. Because I can see that it's just x and x here. And then I can see that 2 is a prime number. What multiplies give me 2, that adds give me 3. Just 2 and 1. Plus 2 plus 1. Right? If you don't see that it's factorable, do the quadratic formula. Complete the square. Or if you just hate factoring for some reason. And then if I solve that equal to 0, I would get x equals negative 2 and x equals negative 1. That's what you did on P6. That's what you did on that worksheet that you got answers for. Sometimes it was imaginary, but you solved them and you got answers like that. What do these actually represent? Zeros. So like on the graph, those are the x-intercepts, the roots, right? All those mean the same thing. So if we were going to graph this, you don't have to graph, but I just want to show you what we're doing here. If we were going to graph this, this would cross at negative 2 and negative 1. And do you remember enough from parabolas? Which way would this open? Would this parabola open up or open down, or you have no clue? Up, because this is positive. If that's negative, it would open down. So it opens up. I don't know where the vertex is. It's somewhere in between here. But very roughly speaking, I could say, that's even rougher there because I missed. It would look something like that, right? And we could figure out whether we're shading inside. If we shaded inside, it would be an and inequality. Or if we shaded on the outside of this, it would be an or inequality. You don't have to graph because we have our shortcut. If you have the quadratic over here and the number on this side, like 0, then it's still the same thing applies. Less than means and, greater than means or. Less than means and, greater than means or. So, step 2 is figure out whether it's an and or an or. Figure out and or and write in interval notation. So solve the equation, factoring, quadratic formula, complete the square, and then we're going to figure out whether we're going to write it as an and or an or statement. And this one, since it's less than means and, that means if I was going to graph this and shade it, it would be shaded on the inside, and I would need to say everything in between -2 and -1. If it helps you to write it as an inequality first, like we could say x is what? Bigger than -2, but less than -1, right? That would be that and inequality. You don't have to write it like that if you don't want, but you do have to write an interval notation. How did I know that that was just less than and not less than or equal to? Here. If that had an equal to sign underneath it, then my answer is going to be included. But technically, this would be like a dotted line if I really graphed it. So I think your answer here should just be -2 to -1. So on your homework when you do these, when I do these, I solve it like the equation, and then usually next to it I write and or, because it just helps me, and then I write my answer. Many people on the quiz for this just forget that it's an inequality. They leave their answer like this, or even worse, they just bring that less than sign down for both of them and forget that we're trying to figure out whether it's an and or an or. How do you feel about that? I know it's been a while since you've done this. Let's do another one, just to make sure we got this. On your homework today, no matter what it says, we're solving these like this, algebraically. So even if it says graphically, I don't think it does, but you're going to ignore the graphic part right now. Step 1 is you want to solve this. So you have some options. If you're going to factor or do the quadratic formula, what's the first thing you need to do to this problem? Yeah, you need to move over to 20. The only way you wouldn't need to move over to 20 is if you were going to complete the square. If you're going to complete the square, what's the first thing you have to do to this problem? Yeah, we have to divide by 2. So either way, you got something to do. I'm not going to complete the square, so I'm going to subtract 20. Because I'm probably going to see if I can factor, or if not, I'm going to do the quadratic formula. So you tell me, you want to factor or quadratic formula? I always check to see if I can factor if it doesn't look too bad. If they're like crazy big numbers, I don't even try. But I would take 2 times -20 and get -40. And if I couldn't think of it, then I would just go to quadratic formula. If you hate factoring like this, do quadratic formula, and we'll see if we match up at the end, because we should. But I'm going to ask myself, what multiplies to give me -40, that subtracts to give me 3, and I think it's 8 and 5, right? I'm going to subtract, so yeah, like this. And I always check my work there. 8 times -5 is -40, and 8x minus 5x is positive 3x, so that does work. So I can bring everything else down. And then I can do that factor by grouping, where I group these together and I group these together. Remember, we want those to be the same. So if I factor out a -5, I think that would work. And for me, I can factor probably just as quick as I can do the quadratic formula, and I don't have to worry about the numbers, like the multiplying part, because I can do this all in my head. But again, quadratic formula is fine. We should get the same answers. Quadratic formula, if you do it, you should get a nice perfect square under your radical, and you could be able to simplify it into 2 answers, and you should get -4, and here, if we add 5 and divide by 2, we would get 5 halves. Do you agree with that? Again, no requirement that you have to factor. I just like to remind you that it's not the worst thing in the world. That would be if it's an equation. It's an inequality, so you have to remember to go back. And less than means and, greater than means or, so we have another and equation here. So if it helps, you can kind of like do this, -4, 5 halves. We want everything in between. This one is included, so I think we would just say that is bracket -4 to 5 halves. And that's really the only extra step you have to do on the inequality. When we do other things in the future, when we do higher than quadratics, like we talk about solving polynomials that are third degree or fourth degree, you can't just use the and or thing because you have more than just and or. But this is a nice little shortcut on this, so you don't have to do a lot of checking. The other thing I want to talk to you about today is projectile motion. There's kind of a lot of writing on this next page, so I'm going to be quiet for a minute and let you write it, and then we will talk about what we can do with this. And actually, to be specific, this is projectile motion on Earth, because if you were throwing an object on the moon, the gravity is different, so the equation is different. And if you want to summarize that a little bit, you can, but I'm just going to, there you go. It's like sub-zero, like, yeah, so like S sub-zero, meaning like the starting. So the big thing, all this writing is really telling us what all these variables represent in this equation. If you take physics, or even if you've taken physics, you'll talk about this equation a lot. You'll probably talk about it in terms of meters per second. So I think it's like negative 32-ish in front instead of negative 16. Because this has to do with the gravity on Earth. But it says, suppose an object is launched vertically from a point s sub-0 feet above the ground. So this I like to call our initial height. So if you're going to take, I like to say just throwing something more than launching something, but you're going to launch something from the ground, your initial height would be 0. But let's say you're standing on a 100-foot tall building, then your initial height would be 100. Or sometimes you're standing in the ground, so your initial height is negative because you're actually below ground. Initial velocity, that's what v sub 0 is. That's in feet per second, so it's kind of how fast it's going to begin with. So that's initial velocity. The vertical position s, in feet, that's your, I call that the new height, or the ending height. I'm going to put new height. After so many seconds. So t is time in seconds. Now this shows up a lot in calculus class. We deal with this a lot. Even when I taught Algebra 1, they showed you this formula for the first time, but you don't use it a lot. But why do we talk about it? It's because this makes the pattern of a quadratic. No matter what you throw up or launch, even if it's a rocket, once the, it's not being propelled anymore. If you take anything and you throw it up, and it doesn't hit the smartboard. If you throw it up out here, it's going to make that parabola shape. And so we get this lovely quadratic that we can solve using completing the square, the quadratic formula, or factoring to find a bunch of different stuff about it. So Sometimes, think about it, would make a very skinny little parabola. Even if you think it's going straight up in the air, it's eventually going to reach that maximum and fall a little bit and make a very skinny parabola, or it could be very wide, like I did. So let's look at a problem that we can do with this, and this is my last one. So, everyone done writing this? Now that I'm on green, because I threw 2 markers. All right, you don't have to write all of this. Let's see. A projectile is launched straight up from the ground level. So let's just put, if you want to shorten this, if you're tired of writing, from ground level. Let's write the bare essentials here. Initial velocity of 288 feet per second. So I'm just going to write that as v sub 0 equals 288 feet per second. And then I think you kind of need to write that last sentence. When will the projectile's height above ground be 1,152 feet? Other stuff we can kind of shorten, but you kind of need to write what we're trying to find. And so anytime you see a question like this, we can use that equation. It always works. S equals negative 16t squared plus d sub 0t plus s sub 0. And you should have enough information to fill in everything but one variable and then be able to solve for that missing variable. So on this one, we're trying to find when will the height be 1,152 feet. So what letter are we going to be solving for on this? What does when mean? When time, right? So we should be solving for t. We don't know the time. How long will it take for it to be that far off the ground? So t is what we don't know. We should know every other letter. So let's kind of go through and see from ground level, which variable does that represent? And that would be 0, right? It's from ground level, so that's just nothing there. I'm not going to put anything there. Initial velocity is 288. So that's negative 16t squared plus 288t plus 0. I'm not going to put the plus 0 there. And then if you weren't sure where this goes, you only have one letter left if you know t is what you're looking for. This is the height we're trying to get to. How long will it take for the ending height to be 1,152 feet? And what we've created here is a lovely quadratic that we can solve. Again, completing the square, quadratic formula, factoring are your options. I like to make my squared term positive, so I'm going to move this stuff over here, whether I'm completing the square, quadratic formula, or factoring. I like this to be positive. You don't have to do it that way, but I'm going to move that over. So I'm going to make this 16t squared minus 288t plus 1,152. Everybody with me to there? Now you have some options. Really big numbers, probably quadratic formula is going to be the easiest thing to do. But don't forget that this is an equation. And if there's really big numbers, am I allowed to divide those out and try to make them smaller? Again, not a requirement, but it's going to make things a lot easier. So I can see right away that these are all even. So at least 2 goes into it. It would be magnificent if 16 went into all these. And I think it does. But even if it didn't go into it, I would at least divide the 2 out and try to make my number smaller before I go here. I think that becomes 18t, and I think this is 72 if I remember correctly. Yeah. And so now that's really not bad at all. I mean, it's even factorable if you want to factor it. But again, quadratic formula with the square, I think those 2 I prefer. I feel like factoring is what we avoid the most. But can you think of this one? Well, multiplies to give me 72, that adds to give me negative 18. 72's got a lot of choices. 6 and 12 it is. 6 times 12 is 72, and if we make both of those minus, we get negative 18 in the middle. Again, quadratic formula should end up with the same answers here. If we're completing the square, wouldn't have been bad on this one. We get t equals 6 seconds and t equals 12 seconds. If we would have got a negative answer there, we'd have to throw it out because you can't have negative time. But we actually got two answers. How does this projectile reach 1,152 feet 2 different times? Right, here's my lovely little projectile motion. So let's just say right here is 1,152 feet. It's going to go up, and then somewhere over here it's going to equal that same time. The only place it wouldn't would be right there at that like maximum or that vertex. That's the only place it would only reach one height. Every other spot is going to be over there, right? Because parabolas are symmetric. So two answers makes sense. So I think I gave you 1 or 2 questions on your homework about projectile motion, and you can probably expect to see one on your quiz on Thursday as well. So if you've looked at your assignment sheet, there's some in parentheses, and it's kind of a big mess on your assignment sheet, so make sure you pay attention here. Your homework is supposed to be 3 through 21 multiples of 3, 34, 38, 40, and 41. But 18 and 21 are with your graphing calculator. So if you want to just write this down, this is what you're doing for tonight. 3 through 15 multiples of 3. 18 and 21 we'll do tomorrow. And then 34, 38, 40, and 41. If you can't handle your homework being out of order, leave a space for 18 and 21. But if you're okay with your homework being out of order, you can just put 18 and 21 at the end of your homework tomorrow when we do the graphing calculator stuff in class. Okay? And you actually have a few minutes that you can get started, or if you have other questions on your quiz that I handed back or your homework,